Hello everyone, may you enjoy a good and happy life. I am Muhammad Asif. In the first lecture of rate of reaction, we have learned about the different type of a chemical reaction: fast, moderate or spontaneous, or slow reaction, and how the rate of reaction can be determined from the collected data. Either we are going to observe the change in pH, temperature, volume of the gas or mass with respect to time. No, in our second lecture, we are going to discuss factors affecting a rate of reaction. Factors affecting a rate of reaction. What are the different factors? The different factors are: number one is concentration of substance. Second is temperature. Third is pressure. Fourth is particle size or surface area of the particle. And the fifth one is catalyst. These are the 5 different factors which affect the rate of reaction: concentration, temperature, pressure, particle size or surface area, and catalyst. Before discussing all these factors, the point of explanation for all these factors is collusion theory. What is the meaning of this collusion theory? Whenever a chemical reaction takes place, then the reactant molecule or particles collide with one another, and as a result of their collision, energy is produced. If the energy produced as a result of collision is too much, which can easily break the bonds of reactant molecules, then reaction will be quickly performed. Older bonds of reactant molecule will be broken down, and new bonds in the products will be formed. As a result, reaction will take place quite easy. If the energy produced as a result of collision is larger than the bond energy of the reactant molecule, this means that the energy of activation for this reaction is low, and the reactants can easily be converted into the products. That can be represented graphically. That energy of activation is low. These are the reactants. This is the energy of activation, and these are the products. Means the energy of activation, which is actually the bond energy of the reactant molecules, is low. So the energy produced as a result of collision of the reacting molecule will be larger than the energy of activation, all of the reactants will spontaneously change into the product and reaction will take place quite easily. On the other hand, if as a result of collision the energy produced is less than the bond energy of the reactant molecules, then the older bond of the reactant molecules will not be broken easily, due to which new bonds for the product will not form and reaction will not take place. Reaction will not take place. For example, in the similar manner, such type of the reactions can be represented just like this. Say, this much amount of energy of activation is required. These are the reactants and these are the products. If as a result of collision the energy produced is less than the energy of activation, reaction will not take place. So, whenever we will perform reaction according to the collusion theory, molecule of the reactant substances will collide themselves, and due to those collisions, energy is produced which will convert reactant into products. Reactants into products. Now, if we use this concept of collusion theory, what will happen? Graphically, we can represent this collusion theory stages as, for example, if this is the molecules of one reactant coming from this side, and this is the molecule of another reactant coming from this side. Both of these will collide with one another, and if as a result of collision their older bonds are broken, then immediately new bonds will be formed quite easily. New bonds will form quite easily and the product will form. The reaction will take place. Now, during this process, as a result of collision, the energy produced weaken the already present bond of reactant molecules and then develop the bond between the reactant molecules, which leads to the production of products. This is the collusion theory which is applicable in all of these 5 factors. For example, if we start considering concentration, if I take 2 solutions in different beakers, if the volume is same and the concentration of one solution is say 0.1 mole per dm cube and the concentration of second solution is 1 mole per dm cube, it is quite clear from the concentration that the particle in second solution, this is the first solution and this is the second solution, the particle present in the second solutions are 10 times more as compared to first solution. Automatically, whenever this solution will perform reaction, as the particles are too much, the number of collisions will also be larger. As a result, larger energy will be produced, and that larger energy will automatically and easily break all the reactant molecule bonds, converting the reactant into the product quite easily. But in case of first solution, as the concentration is less, number of the particles are less, then the lesser number of collision will take place. In other words, the frequency of collision will be very less, and due to which lesser energy will be produced, and automatically the lesser amount of reactant molecule will be transformed into the products. This is the effect of concentration. Effect of concentration. Second effect of temperature. Say, if we take a solution of 0.1 mole per dm cube and perform its reaction at different temperature. Say, the first experiment is carried out at 25 degrees centigrade, and second experiment is carried out at 50 degrees centigrade. 50 degrees centigrade. It is quite clear from the information that at a higher temperature, the kinetic energy of the molecules will be larger as compared to low temperature. So, the higher temperature molecule will collide with themselves tremendously, producing more energy, which will break the bonds of the reactant molecule quite easily, automatically. By increasing temperature, the rate of reaction is also increased. Normally, it is observed that whenever a chemical reaction taking place at room temperature and pressure is increased by 10 degrees centigrade temperature, its rate of reaction becomes almost double. This is the effect of temperature. Now, it is quite evident, increasing temperature, kinetic energy will be increased, more collision will take place, and more energy will be produced, and the reactants will be converted fastly into the products. Next is pressure. Pressure. In case of solutions and in case of solid and liquid reaction, the effect of pressure is negligible. But when the reaction is taking place between gases, then effect of pressure is significant, most prominent. For example, we have already learned that in Haber process, nitrogen reacts with hydrogen and produce ammonia gas. Similarly, in contact process, sulfur dioxide reacts with oxygen and produce sulfur trioxide. Both of these reactions are those in which reactants and products are also gases. That's why in such type of the reaction, the effect of pressure is significant. According to the Boyle's law, whenever we will increase the pressure, volume of the gases will be decreased. For example, in case of Haber process, as equation is indicating 4 volume of reactants, are going to change into two volume of the product. Volume is decreasing. So, according to the Boyle's law, high pressure will favor the reaction in forward direction. Will favor the reaction in forward direction. That's why we maintain 200 atmospheric pressure in this case. Why this pressure is too much high in this case? Because hydrogen is a very lighter gas and nitrogen is the atmospheric gas. To make the collision possible, because the hydrogen is very lighter gas and it will try to escape away from all other gases, so very high pressure is required to make the collisions of both these gases possible. That's why high pressure, not only according to the volume, but for the collision purposes of both the gases, high pressure will favor and will transform the reactant gases into the product gases. In case of contact process, the equation is also indicating that 3 volume of the reactants are changing into 2 volume of the product. It means that according to Boyle's law, high pressure will favor the conversion of the reactant into the products. But here in case of contact process, sulfur dioxide is a very heavier gas. So its reaction can be performed with oxygen which is present in the atmosphere. That's why in this case just only 2 to 3 atmospheric pressure is sufficient. At this pressure, both of these gases will react together and convert it into the product. But what happens actually whenever we will increase the pressure? It means that we are making such an arrangement in which the gas molecules are brought closer to each other so that the frequency of the collision increases, and as a result of increasing pressure, rate of reaction will automatically be increased, because the frequency of the collision will increase, and as a result of the conversion of reactant into the product will also be increased. This is the effect of pressure. This is the fourth one, particle size or surface area. Particle size or surface area. Example of this is, if I take 2 beakers, in one beaker I put larger pieces of calcium carbonate, while in the second beaker there is a powder of calcium carbonate. If I put same volume of same concentration of HCl, what will happen? What will happen, as the second beaker contains powder of calcium carbonate which has a maximum surface area. In other words, the size of the particle is very less, so the reaction of HCl with the powdered calcium carbonate will be much faster as compared to the reaction of HCl with the large pieces of calcium carbonate. It will take too much time, because in case of large particles, from the surface reaction will start and the interior of the solid particle will remain same for a longer time. That's why it will take too much time for the complete reaction. But in case of powdered or very small particle size, the rate of reaction will be much faster. In case of coal mines, it is prohibited to ignite a naked flame. Why? Because in the coal mine, coal dust is present, In coal dust, the coal, which is a burning material, is present in a fine, smaller particle. Whenever we will ignite a flame, those smaller particles will ignite quite easily and explosion will take place. So, such process is not allowed in the coal mining because the rate of reaction as a result of smaller particle size is very fast and very dangerous. This is the effect of particle size or surface area. Now, next is the effect of catalyst. The effect of catalyst. What is the effect of catalyst? Catalyst is a substance. Catalyst is a substance which increases the rate of reaction by decreasing the energy of activation. That can be represented using a graph. For example, if the reaction is taking place in this manner, these are the reactants and these are the products, and this much amount of activation energy is involved. This much amount of energy is involved. Now, this process is uncatalyzed, in which no catalyst is used. Whenever molecules of the reactant substances will collide with one another, lesser amount of energy will be produced, which is less than the energy of activation. So, the reaction will not take place or the reaction will be very slow. But when we add catalyst, what will happen? Catalyst will change the energy of activation. Say, on addition of catalyst, energy of activation decreases this much. Now, this is the new activation energy. This point. Now, as energy of activation is decreased by the addition of catalyst, the energy produced as a result of collision will easily become equal to this lower energy of activation. That's why the reactants will easily be changed into the products. In this manner, all these factors affect the rate of reaction. Now, the most important point here to note is, as I have already explained, concentration of solution is most important, but not the number of moles. For example, if I take 1000 cm cube of 0.1 molar solution, this is my first reactant substance, and the second reactant substance is, say, I take 10 cm cube of 1 molar solution. Say, both of these solutions are of HCl, hydrochloric acid. Now, it is quite obvious, if we find the number of moles, in this case, we know that C is equal to N by V, or N is equal to C into V, volume in dm cube. If we calculate, concentration is 0.1 multiplied by volume is 1 dm cube, because we have to use the volume in dm cube in this formula. That's why the number of moles will become 0.1 moles. In this case, how much? N is equal to C into V. Concentration is 1 molar, and volume is 10 cm cube divided by 1000. What will be the answer? This 0 will be cancelled by this 0, and we will get the answer 1 multiplied by 0.01. Answer will be 0.01 mole. Now, the number of moles of this solution are lesser than this. This contains 0.1 mole, but this solution contains 0.01 mole. These are the number of moles, but the concentration of this solution is more than this. This solution is dilute than this solution. The rate of reaction of this solution will be much faster as compared to this solution. The rate of reaction is not correlated with the number of moles, but the rate of reaction depends upon the concentration of the solution. I have explained all the factors and their effects on the rate of reaction. Hope you have understood all these concepts quite easily. In case of any questions, you can leave the question on Study of Change page.